Now, I don't think we need to turn the light off. It's fine. You can all see that, yeah? Yeah. Alright, so now onto something away from vectors for the moment. Velocity time graph. You might want to write this down. Ah, they went to Starbucks. That's where they went to. What you got? Americano, cappuccino?
Yeah.
Macchiato. Not bad. What do you have? Oh, okay. The only drink I like in Starbucks, they only have it once a year. It's my favourite. The pumpkin latte. You know this one?
Yeah. The pumpkin spice latte for the
Delicious. So good. But only once a year. Oh well. Okay, just before I go on, I just want to double check everybody's here. So, engineering, Andrew? Yeah, okay. Bruce? Yeah, no, I know your name, Bruce, so I don't actually need to know where you are. Monica? Okay. Chrissy? Yeah. Jerry? Yeah, I know Jerry, so that's okay. Now, this is where the names get harder. Cajun? Is that you?
Yeah.
Give me a preferred English name. KJ, I like it. Okay, KJ it is. Next. E? Would you like a preferred English name? He went with KJ, that's pretty cool. You could go with something, no? E? E? Don't know, I think we can do cooler than this. Last name Chu. Just Chu? Pikachu, yeah, we'll go with Pikachu. Pika, yeah, okay. We'll think about this then. And then lastly, Lee. We'll go with Lee.
Yeah.
Lee, okay. Right, I think I can live with that then. Okay, so, like I said, velocity time graph. Did you write that down? Let's have a look at these. Did you check your answers for the last, yeah, and they're all okay? Because if you think there's a mistake or anything, let me know and I can fix it. Alright, velocity time graphs. Yep. Okay. You got this, Bruce? Yeah. Okay, so just before we get into anything too difficult, just to clear something up. So when we're talking horizontally, positive I will use to mean to the right, and negative will mean to the left. Okay. Vertically, you can probably guess here, up will be positive and down will be negative. Okay. Now you knew this already, but this isn't actually a rule. If you wanted to swap so that left is positive and down is positive, this is actually fine. You can actually do this, it's not a problem. And sometimes it's convenient to do this. So we call this a convention. A convention is less than a rule. So a rule you must do, a convention you usually do, but you don't have to. Okay, so we'll just make that clear at the beginning now. So a real number could actually be a vector. So if I say +2, that means to the right, and -2, that means to the left. Or, you know, +3 could mean up, and then -3 could mean down then. Yeah? You look confused, Bruce. No?
Yeah.
You're confused? You know it? Okay, good. Alright, already get. So, yeah, for example, S equals 1 meter, what would that mean? Well, sorry, and I should say that S means displacement here. So if I said displacement equals 1 meter, what would that mean? Yeah, 1 to the right then. 1 meter to the right on the number line. And if I said S equals minus 1 meter, 1 meter to the left then. Okay, so we're all good with this then, yeah? Okay, so now on to definition. Acceleration. I'm sure this is a word some of you already know. Acceleration is a vector. Does anybody know what acceleration is, if they remember from school? Do you remember it? Enough to give me the definition, either of you? No? Yeah?
Velocity time.
Oh, you're so close. So close. But not times.
Oh, half.
What's the word? Not times, not half.
Oh, it's that. It's that
The rate of change of speed.
Close, but also not quite there. Over time. Over time, yeah. So acceleration is the rate of change of velocity per time. And as a formula, acceleration is how much the velocity has changed divided by the time taken to change the velocity. This is the definition of acceleration. So if there's velocity on the top and time on the bottom, what's the units here? I didn't actually write it down. I should write it down here. Velocity is meters per second and time is seconds. So on the top you have meters per second, on the bottom you have seconds, so then it's meters per second squared. Here's the units here. Okay. Got that? Does anyone know the name of this symbol? Delta, very good. And what does it mean? Change, yeah. Okay, continue. Yeah. Yeah. Okay, so just to find some letters here. So, U will use to represent the velocity at the beginning, also called the initial velocity. V is the velocity at the end, also known as the final velocity. A is for acceleration, how much the velocity has changed. T, of course, is for time, how much time has passed while going from U to V. And S is displacement, or position. That is, where is it at the end compared to the start. So U, velocity at the beginning, V, velocity at the end, A, acceleration, T, time, and S, displacement. Please make a note of those 5 letters, U, V, A, T, S. Oh yeah, some people do that. I don't like it. In the exam, they'll probably use the letters U, V, A, T, S. UI and UF, no, VI and VF, very American. Very American, yeah. We don't use that over here, we use U and V. Now the reason I say that as well is because in the formula book, they'll be written using these letters. Did anybody else use VI and VF in high school? V1 and V2. Okay, I don't like it.
INF is better than
yeah, well, it's about the same. It's about the same. Yeah, V initial, V final. Yeah. V1, V2. No, I don't like it. I don't like it. Continue. No, Bruce, right? Did you use UVATS letters as well?
Yeah.
And you notice I called this again a convention because it's not a rule. You can use different letters in different places. Okay. Continue. Yep. Yep. Okay. So we know this dude, world's fastest man. I think, huh?
Not anymore.
Not anymore.
Yeah, it's a little bit.
Okay. Well, at the time I made this slide, he was the fastest. So this is a good example. We'll just use him as an example of UVATS. Okay. So here, when he runs the 100 meters, what's the U? What's the starting velocity?
0.
0, because everybody starts at 0. Roughly, what do you think his V is? That is, at the end, how fast do you think he's going, roughly?
1,500.
Roughly, I just want a rough answer. How many meters per second?
The V?
The V?
25?
Probably a bit, yeah, more. I think more about 12, 13. Yeah. Yeah. A is acceleration, which is this change in velocity. So he goes from a 0 to a 12 or whatever. So it's that's how much of a change in a time of about 9 point something seconds. The T is 9 point something seconds, and the S, we know this one exactly 100. Yeah. Now, warning. Remember, velocity can be positive or negative. In that question, it was all positive. Negative would mean he's running backwards, which is a problem. Speed is only positive because it's a magnitude. It's a length. It's how big the velocity is. So speed is only positive. Velocity can be positive or negative. Displacement can be positive or negative because it's a position, left or right. But distance, only positive. Okay. Do not confuse speed and velocity or distance and displacement. Okay. Just please be careful with that. Speed and velocity are different. Distance and displacement are different. Speed, positive. Velocity, positive or negative. Distance, positive. Displacement, positive or negative. Okay. Now you don't need to write this down. This is just a warning. I'd like you to remember it. Please remember. Some of you will forget. Please remember. Okay. So we'll continue anyways, but just make note if you think you'll forget this. The key note here is that speed, positive, velocity, positive or negative, distance, positive, displacement, positive or negative. Okay? Now, the other thing is, usually, for most questions, distance and displacement is the same thing. Like in the example of the previous slide, S is 100 meters. His displacement is 100 meters. But also, the distance traveled by him is 100 meters. So, usually they're the same, but not always. I would say 90% of questions it's the same anyways. Okay? Right. So we can represent a story by what we call, the name of the lesson, a velocity time graph, where On the x-axis is time in seconds, and on the y-axis is velocity in meters per second. This is called a velocity time graph. So this example I would like you to put in your notebook because everything is represented there. But before you copy it into your notebook, let's just have a look. No, wait, before you copy it, let's just have a look at this together. So we're trying to figure out what's happening in this story. So we imagine that this maybe is a car or something like this. Okay? So here the car starts at rest, at 0 speed. And then some time passes and it accelerates slowly. It's slowly getting faster. What would you describe has happened here? Suddenly speeds up, yeah. Accelerates quickly. Okay? So if this is a car, what might happen? Well, maybe this is the car leaving the home and then it enters a highway, a freeway, something like that, yeah. And then what's happening here at the top? Maximum speed. It's traveling at the same speed. So if this is like a freeway, a highway, it means it's reached the highest speed. Now, what looks like has happened here? Yeah, but not just slow down, like, what do you think has happened in the story? Brake hard. Yeah. Yeah, stops quickly. Student jumps in front of the car. Like this. The student jumps in front of the car, brakes hard. So it slows down quickly. It decelerates. What's happening here? Stopped. Looks in the mirror. See the student on the ground behind. And then what happens here?
Go backwards.
Go backwards. Student isn't dead. Job's not done. Reverse backwards. And then continue at a constant speed backwards. For some reason. So this time velocity graphs are very useful because they really can capture the full story of what's happening by the shape of it. Okay. There's vocabulary here which some of you knew already. So like Jerry said, accelerates suddenly. Here it says accelerates quickly, but suddenly is better. Here accelerates slowly. What way can we describe the top here? Constant speed, or here they say steady speed. Any other words that mean this? Constant, steady, any more? Uniform. Uniform speed. Here's slow down. Jerry, do you know the opposite? No, actually you could still say slow down suddenly. Yeah, slow down suddenly. Or rapid deceleration, which means quick deceleration or fast deceleration. Stopped, speeds up in opposite direction, and then steady speed in the opposite direction, meaning backwards there. So I'd like you to copy this. There are some words here you can write down, but if you know other words, like suddenly or quickly, you can add these to your graph. Okay, so now you can copy this. Make it beautiful, please. Try. Thank you. You made it beautiful?
I think so.
Beautiful enough. Okay, nearly finished there. You have it. Do you have a ruler?
No.
You used a ruler. Yes.
I finished.
Is it beautiful?
I
Show me.
in his man.
It is mine, yeah. Well, let me see yours now, Jerry. Is yours beautiful?
That's very cool.
Maybe actually bad.
It might be a good idea. Yeah, it's useful for physics.
You say
You need a ruler for the exam, yes. Yes. So maybe you should buy one soon. Huh?
Pencil.
You can use pencil. Yeah. Okay, did everybody draw this? Good. Now, here's a short little question we can do. I give you the story and I want you to draw the graph. So a car starts from rest, it slowly accelerates to 20 meters per second, and this took 10 seconds. It then maintains its speed. Okay, what does that mean? It maintains its speed. Constant speed for 5 seconds before suddenly decelerating to rest. What does that mean? Back to zero. And this took 4 seconds at the end. Okay, so I want you to draw this graph with the numbers on the graph, and then I'll draw it on the board. Yeah, it took 10 seconds. Yeah, like this, yeah. Yeah. Okay, some people have this drawn. Yeah. Let's have a look at this one now. So, okay, it starts from rest. That's fine. And then, what speed did it reach? I think we said 20. So this here is a 20, and this here, this is a 10?
Yeah.
And then I said it maintains the speed for how long? 5 seconds. So now this here is 15. And then it decelerates to rest. How long was that?
4.
So we finish at a time of
9.
19 then. Okay, I think everybody got that. Right. This is just a reminder of something that you did in middle school. It is suitable for middle school because in middle school you don't deal with acceleration. Everything is just a constant speed. So as long as it's a constant speed, you have this triangle, which I'll write here and you can copy it here. And I hope that you've seen this before. Oh, come on. Have you seen this triangle? You know what I'm talking about, Jen? So you can say distance equals speed multiplied time. You can say speed equals distance over time, and you can say time equals distance over speed. So you can relate the three here. But what's important for this triangle is that the acceleration is 0. In other words, on the graph, yeah, it's just moving at a constant speed then. Okay. So I just want you to draw this triangle because it is actually useful for some problems. When I want you to use this triangle, I would just say use a distance, speed, time triangle. It's also called Dad's silly triangle. You have DST here. Have you seen it this way?
No. That.
Yeah? No? You're looking up the word silly. Go ahead.
Stupid.
Dad's stupid triangle. Yeah. Okay. Or whatever way you want to remember it. Okay, you got that? Yep. Continue. But it only works when the velocity is not changing, that is, when there's 0 acceleration. So for simpler problems. So what do we do if the velocity changes from u to v? Okay. So if the velocity is changing, we have a little bit of a problem. We can still kind of use this triangle, but the problem is the speed is no longer the speed because the speed changed from u to v. So instead of speed, it becomes average speed. So if you still use this triangle when the speed changes, then what you have is average speed instead of speed. So you could still use it, okay? But just note that it's now become average speed. So let's have a look at what that means for an example. So a boy walks 2 kilometers to school every morning, and it takes him 30 minutes to walk this. What is his average walking speed? Now you know for the boy, he has a u, which is probably 0, and he has a v, which is not 0. So if you were to calculate his speed, it would be his average speed. Because the boy, you know, he starts at rest, he walks, he travels at a constant speed, maybe he sees he's late, so he walks a little faster and finishes walking faster than he started. So if we use that triangle, we get an average speed. That's ugly, sorry. An average speed. A number like this. Okay, so let's calculate it using the triangle. Distance, speed, time. Average speed will be distance, which we said is 2 kilometers, over time, which we said is half an hour. 30 minutes is what we said. So this would be 4 kilometers per hour, average speed. What is average speed? Okay, so a short, simple question, but I really wanted to make it clear what average speed was here. So can you write this one down, or can you do this one? You can just write the first sentence. A boy walks 2 kilometers. It takes him 30 minutes. What's his average speed? So this is the answer here. Okay, so if you can write something down. Yeah? Yes? Yeah? Yeah? So, we know a velocity time graph tells us the velocity at a particular time, but in fact, that is true, but it can tell us much, much more. Let's see. Okay, so I'd like you to write this down for sure, this is important. Okay, so there's our time in seconds and velocity in meters per second. And let me just draw an example here. Like that. Okay, let's see what information we can know. So, we can know the time of the journey, that's here, which is t. Actually, you know what? I mean, if you drew that, that's fine, but I think I'll just put the line up a little bit higher. But it doesn't matter if you drew it down, it doesn't change anything. So this is t. What is this here? This is the starting velocity. So which letter is that? U. And here, this is the final velocity, which is v. Are there other things we can get? Well, there are. Because let's have a look here at the slope of this line. So if we think about it in maths, this point here is 0u, and this point here is tv. And if you remember from maths, the slope, the gradient, the other word for it, that's v minus u over t minus 0, which is the change in the velocity over the change in the time, which we said earlier today, acceleration. So the slope represents the acceleration. But now, let's have a look at what we get here. Yeah, but let's just check why. So this area, let's see what the unit is. So for area, you know, you multiply these two sides. What's the unit here? Seconds, yeah. And what's the unit here? Meters per second. So when you multiply, what unit do you get? Meters. So the area is in units of meters, which means it's actually the displacement, the S. So if you wanted to know how far it travelled, the distance travelled, you can calculate the S from calculating the area here on the graph. So now, all of a sudden, our graph can tell us U, V, A, T, S. It can tell us everything. Okay, can you make note of this beautiful picture, please? Is that the door? No? No? Ghost, yeah. The ghost of the students, I'm sure. What? Nothing.
What is that? GR?
Grad, gradient. It's another word for slope. Yeah, you have this. Yeah, continue. Yeah, okay. So to summarize, U is the height at the beginning, V is the height at the end, A is the gradient, the slope, T is the length, the base, and S is the area. Okay. So here's our first example using the graph to help us answer UVATS. So what I want you to do, just copy this table and then I'll make the graph. Okay, so just copy the table here. Let me open up a nice graph program. Okay, so Bruce, can you just write this table in your notebook? Oops. Discard. Yes. Cancel. Okay, you have the table? You all have the table?
Yeah.
Okay, so let's make the graph. Time, what was the unit for time? I think it was seconds for this one, wasn't it?
Yeah.
And velocity is meters per second. Come on. How do I forget how to make this superscript. Doesn't matter. Okay. So what are the times? I start at 0 and I increase in. Okay, until I reach 10. Okay. And then what's happening here with velocity? Starts at, yeah. Okay, let's make the graph here. Make it beautiful. Chart. Scatter. I'd like the line. Don't want velocity time graph example. X-axis is time in seconds and y-axis is velocity in meters per second. Okay, let's just shrink that a little bit. There we go. So this is my velocity time graph example. You can see here we start off at 0 and we go 5, 10, 15, 20, another 20, and then 15, 10, 5, 5, 5. So this is the graph. Okay, so you'll need to copy this into your notebook. And notice the verb I use. I said plot. Do you remember what this means from maths class? Plot?
Yes.
What?
Has to be neat.
Neat, yes, that's it. Okay, so if you can copy this as neatly as you can in your notebook. Yeah, I think so too. Okay. Yeah, we can look at the rest of the question now. So, after you plot it, the second thing I ask is to use your plot to calculate the distance travelled by the car. So how do we get the distance here? Area, yeah. So, let's see. Actually, you know what? Let me see if I can do it this way. If I have this open and my calculator. Right, so the first area is what shape? Look at this one here. This shape is a triangle, so it'll be, come on, half multiply 4 multiply 20. Okay? Next, what shape do we have next? A rectangle here. Can you see? The base is 1 and the height 20, isn't it? Now the next shape we have to be careful. There's two shapes here. A triangle and another rectangle. So let me just do the triangle first. So what is the height here? No, I don't think so. 15 to here. And the base? 3. 3, yeah. So plus, come on. Plus a half times 3 times 15. And then finally we have this rectangle here on the ground. What is that? 1, 2, 3, 4, 5 multiply 5, is it? Okay, so the F is 107.5 meters in total. Yeah.
But the if here has one rectangle.
Yeah, I think I got that. That was there. The second one, 1 multiplied 20.
Oh.
Yeah, yeah. Thank you. Okay, so I got 107.5. Continue? Yeah? Yeah? Right, next part is, what is the acceleration and deceleration? Okay, acceleration, how do I get that?
Really?
Yeah, and how do I get that for this one? So this is the acceleration. So it'll be 20 over 4. Can you see that?
Yeah.
The slope is the y over the x. The 20 over 4. So the acceleration equals 20 over 4, which equals 5 meters per second squared. And part C now, the deceleration, that's this part. So what is that? Is it 20 over 3? No, it's not 20 over 3. It's, look, 15 over 3. Because this is the triangle here. So it's equal to minus 15 over 3, which equals minus 5 meters per second squared. Yeah? Now please be careful with your English. Yeah? Question? Yeah, so this is exactly what I'm getting to, yeah. So just be careful with your English. So we'd say here, for the part C, acceleration equals minus 5 meters per second squared, which we use the letter A for, or, because they use the word deceleration, D already means minus. So you would actually say deceleration is 5 meters per second squared, because this prefix here, that already means minus. So it's a bit like you're saying minus A equals 5. So A equals minus 5. You okay, Jerry? You look confused. The English, yeah? Yeah. Well, write it down anyways. So just write this one down. I think this is the last one I wanted to show you, isn't it? Yeah. So write that down, and as you're writing that down, let me give you some questions. Yes? Yes, I want lots of pictures. Okay, once you write that down, you can go now. What class have you got next? In C or D? D. And then I think we have class after lunch, don't we? Because I teach... No, I can't switch them because you're different for the physics. Okay. Well, we have maths after lunch.
Yeah.
Oh, but just us. It's a tutorial type of class, is it? Yeah, but I think you're not with the business or the science students for this math class. Like, what room are you in? This will tell us.
1 moment.
Because I think you have 3 hours with me.
Oh, no.
Yeah, but for the 3 hours, is it? Oh, is it? So we have to change in the middle. Okay, see you later then. Oh, wait, I forgot to tell you. So the assessment support, I won't start that until next week. Because the assessment support is to help you with, your coursework and your assignments, but it's too early to start in the first week of teaching, so we'll start that in the second week. So for today, only for today, you don't need to go to the assessment support. We're not starting that until next week. After the maths class, you can just go home, yeah.
Can we do it at least?
Dude, you haven't even finished 1 week yet.